Hello and welcome back to UnHerd. I'm Florence Reed. A new draft report by co-authors at the Pentagon and Harvard University crossed our paths this week, and we found it quite intriguing. So we thought we'd bring it to you and have a little look through it. So far, 2023 has certainly been the year of the UFO. If there was any time to be interested in aliens, it was now, and that's exactly what this report is about. It's authored by Professor Avi Loeb, who's the Frank Bird Jr. Professor of Science at Harvard University, formerly the chair of its astronomy department and the director for the Harvard Institute for Theory and Computation. Professor Loeb is the author of many best-selling books and over 800 papers in astronomy, so he certainly knows what he's talking about. He joins me live from Boston. Welcome, Professor Loeb.
Hi, good to see you.
So let's go back a little bit in time, because to understand this new report that we're looking at, we need to go all the way back to 2017, when an unidentified aerial phenomenon, as you call it, was spotted entering the solar system in quite a remarkable event. Could you just tell me about this unidentified object? It's called Oumuamua. Am I saying that correctly?
Yes, you are. Well, I'm an astronomer. I was working most of my career on black holes, the first stars, and so forth. And the only reason I was brought into this subject is because the first object from outside the solar system was spotted in October 2017 by a telescope in Hawaii. It was given the name Oumuamua, which means a scout in the Hawaiian language. And at first, of course, everyone thought it's a rock from another star that just happened to pass by. And in fact, I wrote a paper about such rocks, anticipating what this telescope might find. And we forecasted that none would be found because they're just too rare. And then this one was discovered, so I was intrigued. And the more we learned about it, the more it looked weird. It was tumbling every 8 hours, and the amount of sunlight reflected from it changed by a factor of 10 as it was tumbling. So that meant that it has a very extreme shape, because the area projected on the sky was changing by a factor of 10. And the best fit for the variation of reflected sunlight was that of a flat object, pancake-like, which is quite unusual. And then this object didn't show any cometary tail. There was no evaporation from it visible, yet it exhibited an excess push away from the sun by some mysterious force. And I suggested that since it's not the rocket effect of evaporating gases, it could be just a reflection of sunlight pushing it. And for that to be the case, the object had to be very thin, sort of like a sail being pushed by light. And of course, if it happens to be that way, then it could be artificial in origin.
The rubber seemed to really hit the road when you used this word artificial, because of course you were stepping outside the bounds of what the rest of the scientific community was saying, which is that Oumuamua was probably organic in nature. And you were suggesting or inferring that it might have been designed. Tell me more about why you might think that.
Well, if it was pushed by reflecting sunlight, it has to be very thin. And nature doesn't make sails that are propelled by reflecting light. And in fact, the same telescope in Hawaii, Pan-STARRS, discovered another object called 2020 SO 3 years later in September 2020, which exhibited the same qualities as Oumuamua. It was pushed away from the sun by reflecting sunlight, and it had no cometary tail. And within a few weeks, the astronomers realized it's actually a rocket booster that was launched in 1966 by NASA as part of a lunar lander mission. And obviously, it was made of stainless steel, so it didn't evaporate. And moreover, it had thin walls, and that's why it was pushed away by reflecting sunlight. And here is an example of an object we know is artificial because we made it. The question is, who made Oumuamua?
And your answer was potentially extraterrestrial life. Is that fair?
Yeah, it's a possibility. I mean, we don't have conclusive evidence. And of course, a picture is worth 1,000 words. In fact, in my case, it's worth 66,000 words, the number of words in my book, Extraterrestrial, which describes the anomalies of Oumuamua. I wouldn't need to write the book. It would save me all the effort if we had a photograph of this object, just like the photograph we have of the asteroid Bennu from OSIRIS-REx, the craft that landed on it.
Did we come close to getting a photo of Oumuamua? This is what I suppose people might not understand, is that it's never actually been seen by anyone. All of the images are a faked up image based on radar pings, or how do we actually get a sense of what it looks like?
No, it was point-like. It didn't come close enough to Earth for our telescopes and even radars to resolve it. So all we know is that as it was tumbling every 8 hours, the amount of sunlight reflected from it changed by a factor of 10. And that led some artists to draw a picture where it looks like a cigar. But in fact, the best fit to the variation of light is that of a pancake, flat object. So we don't know how exactly it looked like. And about a year and a half ago, I established the Galileo project, and one of the goals is to design a space mission that will come close to the next Oumuamua. We have a dating app. I call it dating the next Oumuamua, and the dating app is the Vera Rubin Observatory in Chile that will start operations within a year. It has a camera of 3.2 billion pixels, 1,000 times more pixels than you have in your cell phone, and it will survey the southern sky every 4 days and has a good chance of finding more objects like Oumuamua in the future. And we can, in principle, review them and swipe most of them to the left on this dating app. But if we decide that one of them looks like Oumuamua, as strange as Oumuamua was, we might come close to it and take a close-up photograph. And if we see that it's a rock, so be it. But it could also show some bolts and screws on its surface, and even a label made on an exoplanet. So in that case,
would be very nice and convenient, wouldn't it?
Well, the other thing we will have is the Webb telescope looking at it from a different direction, because it's 1.5 million kilometers away from Earth. And sort of like having two eyes, you have a telescope on Earth and the Webb telescope looking at the same object from different directions. And that would allow us to pin down the trajectory of the next Oumuamua to an exquisite precision and figure out whether it's just propelled by gravity from the sun, or there is something else pushing it. So there is a lot to look for in the future. But in addition, I should say that before Oumuamua was discovered, almost 4 years earlier, was the first interstellar object discovered in the form of a meteor. Oumuamua was the size of a football field, but in 2014, an object roughly half a meter in size exploded in the lower atmosphere of the Earth. It collided with Earth, and together with my student, Amir Siraj, we were able to identify the velocity of this object as being from outside the solar system. It was moving too fast to be bound to the sun. And in fact, the US Space Command under the Department of Defense issued a letter in March 2022 confirming our finding that this object is indeed interstellar. And so we have a published paper, and the data that was released by the US government, which monitors Earth for ballistic missiles, and that's why they discovered it back in January 2014, the data indicates that this object survived all the way down to the lower atmosphere of the Earth, where it was subjected to very extreme stress. And we can say that it was tougher than iron meteorites. In fact, it's 10 times tougher than all meteors ever identified in the same catalog, 273 of them. So the question is was it originating from some unusual source, very different from the solar system? Or was it artificial in origin? Maybe it was made of stainless steel and was a spacecraft from another civilization. And we're going to find out the composition. We are going to the Pacific Ocean this summer 2023 and looking for the fragments left over from this meteor. And by collecting them from the ocean floor, we hope to figure out their composition and tell whether they were just a rock or part of a spacecraft.
Do you have any prediction about what that might be, what that material could be? I mean, we should catch up with you when you get back from that expedition in the summer, but what do you think it might be?
Well, it could be one of two things, either natural or artificial. And in terms of artificial, I should say that my latest paper that was published last week was about a source for interstellar objects of artificial origin. And I imagined pieces of a Dyson sphere. So Freeman Dyson, a British-born scientist, very well known, about 60 years ago, suggested that a very advanced scientific civilization will not just rely on the amount of energy coming from its star to the surface of its planet, but in fact surround the star by a megastructure that would harvest most of the energy of the star. And that is called the Dyson sphere. And it's a huge engineering project to imagine. It could be made of tiles that are floating, hovering above the star, just like sails, very thin. But one thing is clear, that there would be very high stresses on the construction, on the material of this Dyson sphere, and therefore it would be made of very tough material. And I argue that once the civilization loses interest in the Dyson sphere, it may not maintain it, and then asteroids would hit it quite frequently and could destroy it within a billion years. So the pieces of a broken Dyson sphere could float in interstellar space, and they could account for materials as tough as we find in the interstellar meteor that we discovered.
So when we talk about these interstellar objects, why is it that there's so few of them, or seemingly few of them? And why do we see so few of them? Because it feels like to the average layperson that we constantly have telescopes and cameras pointed into the sky, satellites, radars, anything you can imagine, beeping away, trying to work out what's going on in our solar system. So how could we possibly have missed something so big as a football pitch hurtling towards us? How does that happen?
Well, most telescopes used by astronomers look at a small part of the sky, and they're not looking for things close to us. They're looking at very distant sources of light. So, when you are looking elsewhere, you don't find what is close to you. Just over the past decade, there were two important developments. First, the US government established a network of sensors, and that includes satellites and ground-based sensors that are monitoring the Earth's atmosphere for ballistic missiles, for national security purposes. That was constructed only over the past decade, and these were the sensors that discovered the first two interstellar meteors.
So we can kind of thank the Cold War for coming up with these answers. By accident, our kind of paranoia about ballistic missiles has actually worked in our favor here, maybe.
Yeah, it's not just the Cold War. Now there is North Korea. You want to be alert to what's going on, China. And so at any event, science benefits from the investment in military budgets. That happened only over the past decade. And, I feel like the kid in the parade in Hans Christian Andersen's story who said the emperor has no clothes. I basically say this comet has no cometary tail, Oumuamua. So why would you call it a comet? And everyone says, oh, no, there is a cometary tail. You just can't see it. Just like in the story where the emperor had no clothes, but everyone said, well, it's dressed up in a very fashionable clothing.
So it's fair to say that you've caused a bit of a scandal by suggesting, first off, that this Oumuamua comet, or whatever it is, might in fact be of artificial origin. And now a new report, which perhaps is even more scandalous. I'm now starting to think that you might enjoy the scandal of it.
Well, I should say that I just wrote an essay quoting George Orwell. In his novel 1984, he said that in times of universal deceit, telling the truth is revolutionary. Well,
it's certainly a revolutionary idea. I mean, reading the report, it's only 6 pages long. It took me about 2.5 hours to get through it, which is, I'm not a very fast reader, but that's really something for me. And it's basically outlining why an artificial object, like Oumuamua could be, under your hypothesis, might come within orbiting distance of our solar system, our Earth. And the conclusion you come to, and I'll read from the report because it does read like science fiction, so I want to get it absolutely right. An artificial interstellar object could potentially be a parent craft that releases many small probes during its close passage to Earth. So tell me, what are these probes?
A very good approach to probe a large region of space is to release many small probes. And, that is the approach that dandelion takes in seeding the environment. Dandelion seeds they have their own parachutes, and they land on a wide area. And if you have a probe that has an intent of visiting the habitable zone of a star like the sun, the probe itself might be too big and move too fast to land on a particular planet. And also, if it lands, it would be just one geographical location. And if you want to probe a lot of regions and a lot of planets, you might just spread dandelion seeds, like small probes, mini probes, a swarm of probes around the habitable zone. And that's a more effective approach. And in fact, just this year, we founded a new space corporation with my colleague, Dr. Frank Laukian, that aims to use this approach for the moon and Mars instead of the traditional approach of using just one big probe and visiting one location. You might just spread your bet and have a swarm of small, tiny mini probes that go around. So, by the way, I don't like science fiction. I really enjoy doing science and reading fiction, but the combination of the two makes me anxious because I cannot enjoy the art when it violates the laws of physics. I'm trained as a scientist. I cannot think that something would move faster than light, that you would have all kinds of phenomena. Because if it were the case that there is new physics, it would be employed in our technologies. We know so much about reality using all the experimental data we have so far. So science fiction very often violates what we already know, and I don't like that. But in this paper with Sean Kirkpatrick, we just use science as we know it and try to constrain what we can say about objects entering the atmosphere, like these probes that we were discussing.
Within the constraints of the science that we know, then, how can we conceive of how these probes might work in a kind of hypothetical reality?
I read a paper that was posted by Ukrainian astronomers who argue that they see dark objects in their sky moving really fast. And they argued from one vantage point that they can estimate the distance, and these objects are at a distance of about 10 kilometers. They're moving at 15 kilometers per second, really quick, like fast moving across the sky. And they have a size of about 10 meters. And I thought to myself, that makes no sense whatsoever, to have a dark object moving faster than the escape speed from the Earth. That's science fiction, by the way, because what will happen is when it moves that fast, it will have friction with the atmosphere and will heat up the atmosphere, create a fireball, just like meteors do. And it would not be a dark object. The fact that it's a dark object means that it interacts with light, it blocks light, so you can't avoid interaction with the atmosphere if you interact electromagnetically with light. So any object that appears dark, cannot avoid producing a fireball. And
so
therefore,
under those conditions, it should have looked like a meteor shower, that kind of phenomenon that we see, that we all gather outside to look at in the sky.
Yeah, it would have been a giant fireball. The meteor, like the one I mentioned, that was half a meter in size, released about a few percent of the energy output of the Hiroshima atomic bomb. Every year, there is an object the size of a person colliding with Earth and releasing as much energy as the Hiroshima atomic bomb once a year. And usually it's at an elevation of 30 kilometers, so it doesn't cause much damage, and it's often over the ocean. So we don't hear about that, but it's easy to see. It's a huge fireball. And so the point is, the report from the Ukrainian astronomers indicated that they are miscalculating the distance, that if you bring these objects, dark objects, closer by a factor of 10, then the speed by which they are moving is reduced by a factor of 10. And so they are moving at 1.5 kilometers per second. And their size, instead of being 10 meters, is 1 meter. So I said, well, it's artillery shells. They're looking at artillery shells. Or if you bring them even closer, it could be birds, it could be, bullets, whatever. In a military zone, all these things are possible. And the dark objects moving that fast cannot be so far away. So we use this in our paper with Sean to argue that if you don't have a good distance estimate, then you can put a constraint on the distance from the fact that you don't see the fireball. Or there should also be a radar signature from the heating of the air that breaks down the molecules of air and releases some free electrons out of them.
Two obvious questions about these probes then. Firstly, how do they propel themselves through space? How would they end up landing on Earth? Are they powered by computing systems, AI? Are they organic in nature? I suppose that's the first thing. And then the second thing is, you use this analogy of the dandelion spore, the seed that comes down and lands on the Earth. But what happens after it lands on the Earth? We know that it grows a new dandelion. So is the insinuation there that the probes coming off this mothership are actually being sent to propagate a new alien species on our planet?
Right. So the answer to the first question depends on the nature of the engine. And the only type of engine that we employed so far for interstellar probes was chemical rockets that can push a probe up to about 1 part in 10,000 of the speed of light. And they have the advantage that they can accelerate a rocket, but also slow it down. And now this is one of the concepts envisioned by SpaceX for landing on Mars, slowing down the Starship. So that's what we use. But obviously, we developed it only over the past century, this rocket technology. And there could be much better schemes. For example, a light sail being pushed by light. When a probe comes into the Earth's atmosphere, in order for it not to burn up, it could use a parachute just to slow down and then eventually reach the surface. And then the engine can use water or any other nutrients as fuel. And it really depends on what the engine is made of. And, we can go to various other possibilities, like, for example, a very distinguished British cosmologist named Hermann Bondi wrote a paper in 1957 suggesting that if you have a negative mass, because usually we are used to positive masses, but if you have a negative mass, which in principle is possible to construct, because I'm writing a paper on it right now, then the negative mass will push away if you put a positive mass next to it, and the positive mass will pull the negative mass with it. So together they would accelerate indefinitely up to the speed of light. That is a type of an engine that we have never constructed and could potentially be engineered if we develop the physics behind it.
This is where we hit a kind of mental hurdle, because we have to assume, I suppose, under your reasoning, that an alien species may have far more sophisticated science than we do. And so when we speak of alien technology, we have to imagine that their technology is far, far better than ours can even conceive of being. This is, I suppose, where we hit a problem, because most people are used to the image of aliens as being coming down in a kind of slightly tinny rocket and beaming down on a kind of stream of light. What you're speaking about is something completely inconceivable to our ideas of modern technology.
Yeah, and the way I think of it, it's just like going on a date. You could learn from the other person. We should look at it as an opportunity. We shouldn't be fearful of that, but instead, we are probably not sophisticated enough for us to be a threat to whatever comes to visit us. We can make money from it if, entrepreneurs, if they learn how to replicate it here on Earth, they can make money of it. But moreover, we can get a leap into our future. As you know, there are no time machines, but if most of the stars formed billions of years before the sun, and if there was another technological civilization that had more than a century like we had for the development of its science and technology, we can learn from them and get a leap into our future, technological future. Now, you asked also a question of what they might be hoping to accomplish. And here, the way I think of it is, if you stay on your planet, then you might be annihilated or destroyed by a single point catastrophe, like if a giant asteroid impacts the planet as the dinosaurs were killed, or if we develop technologies that, as we know, can produce self-inflicted wounds on us. We will eventually change the climate or end up in a state where we won't be able to survive on this rock. And so I'm saying that it makes sense for humanity to explore space and send systems that can replicate what we find precious here on Earth. And These would most likely be artificial intelligence astronauts, systems that are autonomous. They are not waiting for guidelines from us, but they pursue some goal of For example, you can send them to another planet that is habitable, just like Earth, and program them to establish intelligent life on this planet using whatever we know from our science, or in the future from our science. And if we can imagine such a thing, sending probes to habitable zones around other stars, then they may have done that. And that comes back to your question, what are these probes seeking? We will not know until we observe them. And I don't think it makes sense to establish a committee of experts sitting around the table and making various scenarios and deciding what is the protocol, how to respond to a visitor in our backyard. Because I think, as you said, our imagination is limited by our experience. And the best thing to do is listen. If you go on a date, here is an advice: listen to the other side. Don't speak so much. And we should adapt this attitude towards interstellar visitors. We should just try and figure out what they're seeking. I had a Zoom call with Henry Kissinger just last year, and I asked him, because he negotiated with China, with other nations where the culture is very different. And I asked him, what is the realpolitik of interstellar communication? How do you respond to that? And he said, yeah, he basically agreed that first you want to learn what the other side is seeking, and only then develop a dialogue with them.
Is there any actual evidence, in the same way that we had evidence with Oumuamua from the observatory in Hawaii, is there any evidence from observatories or telescopes that these probes are actually entering our solar system? Any data?
Well, the point is that the government collects data as a result of national security concerns. And as a result, the sensors the government is using are classified. And as a result of that, the data is classified, not because of the content of the data, but because it was collected by classified sensors. And the US does not want adversaries to be aware of the quality of the sensors that are being used. And then what happens is that if there is high quality data, it's not being released to the public. An extraterrestrial technological object has nothing to do with national security. It doesn't adhere to national borders. And therefore, any knowledge about it should be shared by all humans. It shouldn't be the privilege of the President of the United States.
But you can see the problem here, of course, that if they are monitoring for security reasons unidentified objects in the atmosphere, then of course there has to be some element of classification around those documents that reveal what objects have been shown. So we're in a bit of a bind here, because the government is not a scientific institution, but it's also doing the best kind of monitoring that's possible to be done. And so we have these two things. How do we actually get the information out of them?
Well, so there are two possible ways forward. One, the sky is not classified. As we know from astronomy, we're looking at the sky. So if we just build the right set of instruments, we can collect the data. Waiting for the government to declassify data is like waiting for Godot in Samuel Beckett's play. You can wait forever. My point is, we can take our future into our own hands and collect the data ourselves. That's the way science is done always. And then the second approach that in principle one can take is to encourage more people to look at the sky, allocate more funds to the search globally. And as of now, for example, humans are spending $2 trillion a year in military budgets. And if we were to allocate a small fraction of that to just figuring out what is out there in the sky by better telescopes, better monitoring systems, not just finding them serendipitously, all these objects like Oumuamua, the interstellar meteors, and unidentified aerial phenomena, but just having a dedicated research program, scientific research program, just the way we are searching for the nature of dark matter. We can search for the nature of objects near Earth. And since the public cares so much about it and the government cares so much about it, it's our civil duty to do it. I see it not as a contradiction, but actually a fulfillment of the role of a scientist to explain things to the public, to the government, rather than leave them unexplained. And often my colleagues argue on committees that allocate federal funds, they argue we don't want to take risks because we don't want to waste taxpayers' money. My point is, why don't you ask the taxpayers what they really want? Because if you were to ask them, they will argue that they want to know the answer to this question that I'm discussing much more than they want to know the nature of dark matter, to which you allocate the funds very easily. We spent $10 billion on the Large Hadron Collider searching for the lightest supersymmetric particle in the parameter space where it was predicted to be, and we didn't find it. But that's the way science is done at the frontier. So why are we considering that as less speculative than the possibility that we are not alone? We know that we are not at the center of the universe. We know that there are billions of other Earth-Sun systems in the Milky Way galaxy alone. So if we are not at the center of the stage and we just came to the cosmic play at the end of it over the past few million years as the human species, the play is not about us.
Tell me what it's like being an expert in aliens. It seems like it must be quite an odd field to choose as your specialism.
Oh, well, just because of that, because I grew up on a farm. The way to think of me as a farm boy, that explains a lot of things. First, that I'm connected to nature more than to people. I have no account on social media. I don't care how many likes I get. I'm just trying to do what sounds like common sense. And common sense is not common. Very many times when people say you're thinking outside the box, it's simply because the box is in the wrong place. And the public gets it. The public really cares about this question. Something is wrong with academia, where people are obsessed with their self-image, with trying to gain honors and awards based on past knowledge. I think this is the most fascinating question that we can address. Now, the second part of my upbringing was that I remained loyal to my childhood curiosity. I'm simply curious. If Oumuamua looks strange, I want to figure out what it is. I don't want to argue it's a rock and move on, because that would look like a cave dweller finding a cell phone and arguing the cell phone is a rock of a type that I've never seen before. And I would rather be the kid of the cave dweller looking at this unusual object and trying to press some buttons and figuring out that it's not a rock. So it's just driven by curiosity, but also modesty. It's really not about us showing off. And, there are many of my colleagues working on extra dimensions, on the multiverse, doing fancy mathematics, and it's their way of showing off that they are smart. But reality is under no contract to require that. If there is an object from another civilization that could change the future of humanity, it may not require fancy math to realize that it's not a rock. So it's not about us showing off. Academia is not supposed to be about us showing off by fancy math that by doing string theory we are smart. This is not really what we are supposed to do. We are supposed to describe reality. So when there is data about something unusual, we are supposed to be curious, not supposed to ridicule anyone suggesting a possibility for what this object might be.
I suppose the difference there, though, is that if you take a multiverse theory, there aren't that many people who have embedded themselves in a kind of mythological idea of the multiverse. Whereas if you ask, someone about aliens, you might get two answers. You might get something akin to what you're saying, which is, look, it's worth looking at the possibility and taking all of the evidence we have and reading it closely. And you get the other answer, which is, yes, I do believe in aliens, and they abducted me last night and probed me in my sleep. So this is the problem. We don't get people like that talking about string theory.
Well, that's an excellent point. So indeed, on this subject, you have polarization, just like political polarization, where there are people that are believers. And by the way, it's not very different from religious beliefs or any other beliefs. People that believe but do not believe in the scientific method. In other words, they are not subscribing to the collection of evidences guiding us. And they claim all kinds of claims that are not substantiated by data or by evidence. There is this part of the subject. And yet at the same time, you have scientists not wanting to sleep in the same bed with those people. So they are pushing to the opposite extremes. And what makes most sense is actually going in the middle, using data and evidence to figure out the cosmic neighborhood that we live in. So that's what I'm advocating. And, it's not easy to stay there, as you can imagine, but it seems to me like common sense.
This seems to have happened a little more during COVID as well, that scientists for fear of being associated with people who have unscientific views, have pushed themselves towards the idea of hard science, hard line, almost religiosity in science.
But the point that is being missed, which I'm really frustrated by, is that scientific knowledge should be based on evidence. This is the guiding principle, because we have wishful thinking and we have ulterior motives for promoting some ideas. So, in the context of string theory, it's the idea that fancy mathematics of extra dimensions can describe nature. There is no evidence for that. For 50 years, people have been working on it, producing a lot of papers. The problem I have is with the lack of evidence to support or test the idea, because very often fancy ideas are proven wrong. Even Einstein was proven wrong 3 times at the end, between 1935 and 1940. He argued that there are no black holes, that gravitational waves don't exist, and that quantum mechanics cannot have spooky action at a distance. And over the past 5 years, the Nobel Prize was awarded to 3, in these 3 categories, to 3 groups of people that proven Einstein wrong experimentally by evidence. So I'm saying, when you work at the frontiers, there is uncertainty. You can be wrong. That's part of the job description. But avoiding that job risk and trying to argue, let's work on topics that we cannot test by experiments, just because we will always be right, we can always show that we are smart. That's a betrayal of the tradition of physics. And to me, we are, there is a whole community of theoretical physicists that went in that direction. They are considered part of the mainstream. And I think that the mainstream should be based on evidence-driven knowledge, because we were wrong many times before, and we might be wrong also in the context of interstellar objects. The other thing I wanted to make, to point up, is that what we find in the solar system clearly does not represent what is outside of it. We know that from the fact that most of the matter in the universe is called dark matter. It's not the matter we find in the solar system. And now these interstellar objects seem to be different than the asteroids and comets that we had seen before. So let's just study them.
So let me just take the other side here, because I suppose if you are a young junior professor at a university like Harvard, then you might feel that stepping outside the bounds of what's considered kind of acceptable science is too risky, given this economy, given the moment we're in with declining funding for anything experimental. So what do you say to that junior scientist who is not willing to step outside the bounds of what's considered reasonable?
Yeah, so in fact, this question was raised by 3 junior scientists who visited my office 2 weeks ago. And they asked me for career advice. They were prospective PhD students at the Harvard Astronomy Department. And by the way, I was the chair of the longest serving chair of the Harvard Astronomy Department between 2011 and 2020. So I have a lot of experience with the academic system. And my advice was, if you look at the career of Pablo Picasso, you will find that early on, he was a realist. He tried to draw in the style of traditional painting, okay? And after he mastered that, he invented cubism, which was disruptive. So as a young scientist, fledgling scientist, you don't want to disrupt the system too early. So what you want is to learn, first of all, the basic principles of physics and apply them along the themes that are defined by senior people in academia, so that you can get a postdoc position after your PhD. And after that, you get a junior faculty position. And eventually, you're promoted to tenure. Now, this is extremely important. The meaning of tenure is allowing you freedom. You can break loose of the box that confines your thinking. But what really happens is that after people get tenured, they are even more obsessed with their ego. They want to get honors, awards, to be recognized by their peers. And as a result, they conform to the beaten path. And I say that the road not taken is the most interesting thing to take, because it may have low-hanging fruit in it. Nobody picked it up. So I advise those young scholars, if you are interested in innovation, once you get tenure, you start to be creative, innovate, because that's the whole purpose of academia. Discover new knowledge. And then basically betrayed the slogan of the party in George Orwell's book, 1984, which said, ignorance is strength. I argue, and I argued it to my undergraduate class yesterday, I said, knowledge is strength. And knowledge involves going into virgin territories that nobody went into before and trying to figure them out. And you might be wrong at times. That's okay. That's part of the process. It's a learning experience. And we shouldn't pretend that we are experts, that we know everything. We should just explore. That's the privilege of a scientist. So that's, I think, what academia should be about. But unfortunately, it's not. And I just heard a few days ago of a very distinguished scientist who said, I don't really want to know whether COVID-19, the virus, came from a lab leak or the wet market in Wuhan. And why would he say that? A very distinguished scientist, because he doesn't want the image of science to be tarnished if it came from a lab leak. And I say, this is similar to arguing that ignorance is strength. No, we want to know so that we can prevent another Chernobyl, in this case, in the context of biological warfare. And we just want to know the source no matter what. Knowledge is strength. And the same is true about the nature of unidentified aerial phenomena, the nature of dark matter. Everything should be driven by our ambitions to be knowledgeable, because then we can adapt. Even if reality has pimples, even if you don't put any makeup on it and it doesn't look as pretty as it should be, let us see it.
There is no doubt in the top epidemiologists of Harvard, Stanford, Yale that COVID does exist. So the arguments then come underneath that. Whereas in this context, there is a genuine cohort of your colleagues who would say that there is 0% probability that aliens do exist. So can you give me some probability from your sense of the evidence as you see it? What do you think the probability is for there being a life beyond the life we have on Earth?
Well, first, a footnote. This is not new. It reflects on them more than on me. But if you look back 4 centuries ago, Galileo Galilei was put in house arrest just for suggesting that maybe the Earth moves around the sun. And today he would have been cancelled on social media. If you were to ask those theologians, they would say there is 0 probability that the Earth is not at the center of the universe. Now, why would they say that? Because the church wanted to control people. So they wanted to argue that humans are the center of attention of God. Anyway, there are always ulterior motives for people to argue one or another. Another thing that I should say is that there was a congressman in the US that retired a few years ago, and he was known for making anti-gay statements. And then when he retired from Congress, he confessed that he is gay. So what does it tell you about human nature? That people can argue that there is 0 chance, but deep down they are really intrigued by the possibility. And I bet you that if we find a piece of technological equipment from another civilization, these same people will say, of course, this was talked about for decades. Look at this book, look at that article. There is nothing really new. We knew it all along. And the reason I say that is because when exoplanets were discovered, everyone did the same. But a few years before that, this idea that other stars have planets around them was considered fringe. I was a postdoc back then. So this is human nature. It says more about those people than about me. But if I had to guess, I would say not only that we are not alone, that there were many technological civilizations before us that reached greater heights. We are probably not even close to the top half of their advances. That what I tell students in my class at Harvard is that half of them are below the median. And they have a hard time accepting it, even though the median is defined statistically so that in every class, half of the class is below the median. There is no escape from that. And the question is only who are the students that are below the median, but it's a statistical fact. And the students at Harvard, all of them want to think that they are at the top. And so, the same is true about humans in general. They want to think, oh, there is nobody else out there. We are the smartest. But, and actually, Steven Weinberg in his book, The First 3 Minutes, towards the end, he says, the more the universe appears to be comprehensible, the more pointless it looks. And I say it looks pointless to Steven Weinberg and also to the cosmologists and my colleagues that say that there is no chance of finding anything. It looks pointless because we didn't find a partner. Because if you extrapolate from our private life, when you find a partner, it gives meaning to your life. So I argue that once we find partners in interstellar space, it will give meaning to the universe. And it could unify religion and science because there would be beings that are far more capable than we are. They would have technologies that look like magic to us, sort of like miracles in religious texts. And it's possible that civilization could create life in its laboratories, could create a baby universe in its laboratories, things that we cannot imagine. So it would bring the concept of God or something very capable into reality. It would unify science and religion in some sense. And I think it's very likely that they were out there billions of years ago, maybe not right now, but they existed. And the only question is, when will we find the conclusive evidence beyond any doubt? And for that, we need to do the search. So I'm engaged in the search. And I think that in the coming years, if there are objects of technological origin, we will find them.
My very final question for you, Dr. Loeb, is about humanity as opposed to alien life. I said in my introduction that people seem to be more and more interested in alien life, and 2023, as I mentioned, has already been a year full of speculation about extraterrestrial existence. What do you think that tells us about human beings and what we want?
Oh, I think everyone wants to find a partner out there because if you look at human history, it's very depressing. You often find groups of people trying to feel superior relative to other people. But just imagine there is someone far more capable than all of us out there. Then our differences are meaningless. And we should treat each other as equal members of the human species. This is really the message of modesty that we can get from the cosmos. And I think people are tired of, engaging in wars and wasting, our energy on polarized ideas. Rather, let's find something uplifting. And I just submitted the proofs for my next book, Interstellar, that will come out in August 2023. And I was asked for an epigraph, a brief statement that summarizes it. And I'll just give you that scoop. And I wrote that I'm seeking a higher intelligence in space so that we will know what we can aspire to be.
Professor Loeb, thank you so much for your time.
Thanks for having me.
That was astronomy professor from Harvard, Avi Loeb, speaking about the potential for alien existence beyond our terrestrial lives. He took to the philosophical there towards the end of our interview and suggested that perhaps our desire to find what he calls partners in another dimension or another galaxy is exactly what humanity needs right now. We will look forward to catching up with him again in the summer after his expedition to go and look at some of these potential probes, and we'll see what he finds. Thanks to Professor Loeb for coming on, to you for watching. This was UnHerd.